Just 1 minute. ठीक है, this one. बस ये मुझे confirm कर लो. Was this the last thing that we were doing? इसी पेपर से हम start करते हैं. और 1 minute. चलिए ठीक है. So we're going to start with the same paper जो हम last time कर रहे थे. Transition element की definition से we're going to start, and that is कि it forms stable lines. I think this was the last thing that we did. It's going to form stable lines with incomplete D subshell. Just so with incomplete D subshell. With incomplete D subshell. I said the other thing is the following. It shows some reactions of copper H2O6. So what happens when Cu surrounded by 6 water molecules and you have an OH minus 1? So in say what happens is you have to remember all these ligand exchange reactions. 2 of the water molecules, they get substituted by OH ions. And you get CuOH2 and H2O is 4. And overall it's neutral. It's a solid precipitate. This is a pale blue precipitate, but then it's he hasn't asked for the color. Just for revision. Pale blue precipitate is formed. This is a precipitation reaction.
सर ये कल हम लोगों ने इसको ब्लू ग्रीन नहीं बोला था, वो कॉपर एक्वस क्रिस्टल्स को.
नहीं, वो Cl-1 के साथ किया था. जो लास्ट हमने किया था ना, ग्रीन जो हमने था, दैट वाज कहाँ पे था वो? हम एग्जैक्टली यही पेपर कर रहे थे. वो भी डूइंग अ डिफरेंट पेपर.
आई गेस यही वाला था.
यही था ना
ये सर.
लेकिन वो जो ग्रीन है ना, ग्रीन येलो ग्रीन जो था, दैट वाज दिस वन. ये जो सेकंड वाला है Cl के साथ. अच्छा जस्ट 1 सेकंड. ये मुझे दोबारा लोड करना पड़ेगा, क्रैश कर गया. जस्ट गिव मी 1 सेकंड. अच्छा कौन सा था? 9701. अच्छा it was 9701 and I think W16 and it's QP43, right? चलो सारा ये हट गया. अच्छा क्वेश्चन नंबर ये सारा हो गया था. क्वेश्चन नंबर
Question 4, I think.
ठीक है. क्वेश्चन नंबर 4 and also let's open the answers check करने के लिए we can open the marking scheme and we need the data booklet as well. So this one, question number 4. So we did the first part. What happens when you have Cl-1? Okay, when you have Cl-1 as a ligand, what's going to happen is CuCl4, and the total charge is going to be 2 minus. Okay? A tetrahedral complex is going to be formed. And when you have NH3, then the water molecules are going to be surrounded by NH3s. You could have all of them getting surrounded by NH3s, or you can have 4 of the water molecules getting substituted by NH3. Leave 2 water molecules there, and the whole thing would have a charge. The complex ion would have a charge of 2 plus. Okay? The reason why we are leaving some of the water molecules is it's aqueous. So इसलिए I'm leaving some of the water molecules there. And then you're being asked to state the color of the solutions. Copper with water, that's blue in color. Solution B, Cl minus 1 के साथ, that was green/yellow, greenish yellow. And C with NH3, the solution is deep blue. Okay, so you have a deep blue solution with NH3. Where standard electrode potential has to be defined. So what is the standard electrode potential?
The difference between the SHE and standard hydrogen electrode.
It's the potential difference. ठीक है, sir, your answer is right. Potential difference between a standard electrode and a standard.
You also say the conditions.
I mean, it would be better if you wrote the conditions as well, because you're writing standard conditions. So it's the electrode potential between a standard electrode and a standard hydrogen electrode. Okay, that's your reference electrode. Measured under standard conditions. And you can add the conditions in the bracket just to be on the safe side. Because the word standard is used. Okay, remember, whenever you have a definition and the word standard is used, you always have to mention the conditions in the bracket. So it's 298 kelvins and 1 atmosphere pressure. And if there's any solution, that's going to be 1 mole per decimeter cube. Next question is, you're given complete the table and used to make the electrode in each of these half cells. There's an electrochemical cell. There's copper 2 plus, cobalt, and he's asking, what is the substance? What is the electrode made up of? Remember, if a metal is involved in the electrode reaction, then the electrode is made from that particular metal. For example, in this case, cobalt would be the metal electrode, and the solution is going to contain the cobalt 2 plus ions. So it's going to be made out of cobalt. And if the electrode reaction has ions only, then both Fe3 plus and Fe2 plus would be present. They're going to be present in the solution. They would be gaining electrons and they would be losing electrons. And your electrode is going to be a platinum electrode that's going to be added. So it's going to be made out of platinum. So the only time the electrode is not made from platinum is when the metal itself is involved in the reaction. Then the metal is the one that's used as an electrode. You have to write the equation for the overall cell reaction. For that to happen, you would have to first figure out the electrode reactions. There's Fe3 plus in equilibrium with Fe2 plus. You can open the data booklet. The value is 0.77 volts. And then there is cobalt 2 plus in equilibrium with cobalt. The value you can have a look at the data booklet. This way there is over here in C, you can see cobalt somewhere over here. That's cobalt 2 plus in equilibrium with cobalt, and that's given as minus 0.28 volts. So this one is minus 0.28 volts. Now, how do you decide who gains electrons, who loses electrons? So the rule is that the higher potential is the one that's going to get reduced, that's going to gain electrons, and the lower potential is the one that's going to lose electrons. So the first one is going to go in the forward direction, the next one is going to go in the backward direction. And to make the overall cell reaction, what the first thing you have to do is balance the number of electrons. So I'm going to multiply this equation with 2 so that the number of electrons gained and lost, they become equal. Once that is done, you add up the reactants. What are your reactants? In the first one, the reactant is Fe3 plus. So that's 2 Fe3 plus. And in the second half equation, the reactant is cobalt. And what are your products? In the first one, the product is 2 Fe2 plus. And in the second one, the product is cobalt 2 plus. Okay, remember the main goal of the main idea of electrochemistry is that higher potentials, the reason they are higher potential, the reason they're positive is because the substance likes to gain electrons, which is why the electrode becomes positively charged. And the reason why this is the lower potential is because the substance likes to lose electrons, which is why there's so many electrons over here on this electrode that it becomes negatively charged. Higher potential gains electrons, lower potential loses electrons. And then the next part is he's asking you to calculate the E0 cell. The E0 cell is going to be higher potential minus lower potential. It's going to be 0.77. And you're going to minus the other one, minus 0.28. So just like physics, you're going to have higher potential minus lower potential, or you can call this reduction potential minus oxidation potential. So what is the value you're getting, Sarah? What's the value?
1.05.
Because this one is 1.05 volts. Now, next one is the electrochemical cell in B was set up again, but this time the concentration of cobalt 2 plus was 0.05 mole per dm cube. Now he's changing the concentration. Now this is not standard conditions. Now, since it's not standard conditions, you calculate the new potential using the Nernst equation. And he's saying use the data booklet and the Nernst equation to calculate the value of E for the cobalt 2 plus half cell. Now everything is given. You just have to find the new potential. Because remember, if the concentration changes, the electrodes over here, the equilibrium is going to shift. He's decreasing the cobalt 2 plus concentration. Ignore the whole thing, just focus on this reaction, or we can write the reaction over here again. Now this is the reaction. Now standard potential is minus 0.28 volts. But what's going to happen is, okay, if the reaction is not under standard conditions, and the concentration of cobalt 2 plus is a lot lesser than 1 mole per dm cube. So if it's a lot lesser than 1 mole per dm cube, the equilibrium is going to shift in the backward direction. You decrease cobalt 2 plus concentration, the equilibrium tries to make more cobalt 2 plus according to the Le-Chatelain principle. So more electrons are going to be produced, and the new potential would become more negative, or you can call it a lower potential. It's going to be a lower potential. Why? Because the equilibrium is going to shift backwards and it's going to produce more electrons. So I'm going to use the Nernst equation to find this new potential. So it's going to be the old potential, which is E0, which is minus 0.28, plus 0.059, where Z is the number of electrons in the equation. So it's 2 in this case. And it's log of oxidized species, which is cobalt 2 plus in this case. And the concentration that's given is 0.05. So can anyone do the math and tell me what the value is?
Is it negative 0.32?
Negative 0.
318. Negative 0.318.
318. Okay, let's have a look. I mean, that it makes sense. It should be more negative. That makes sense, and we can have a look at the just to check. Probably this one. It's negative 0.318. Okay, that's fine. I just suggest how the change will affect the overall cell potential E cell compared to E naught cell. So how would this change affect it? So if it's not minus 0.28, and instead if it's more negative, minus 0.318, then what would be the overall E naught cell? The difference is going to be larger. Higher potential minus lower potential, that would increase in value. So it's going to become more positive. Okay, the difference is going to be much higher. फिर वो कह रहा है iron 3 ions can oxidize vanadium metal. Construct an equation for the reaction of iron 3 ions with vanadium metal. Use of the data booklet will be helpful. And it's a 2-mark question. Now this question over here is kind of, I mean, we can bring in what we can do is we can do a working on the data booklet. Where's the data booklet? Just one second. So we're going to do the working on the data booklet. He's saying iron 3 plus. So what I'm going to do is I'm going to mark all the equations where there's iron 3 plus involved. So there's this equation. So I have Fe3 plus gaining 3 electrons. And I have another equation where Fe3 plus is gaining just 1 electron. So one of the value is a lower potential. The other one is kind of a higher potential. So Fe3 plus is capable of doing either of these. It's capable of gaining 3 electrons. It's capable of gaining just 1 electron. So it's Fe3 plus reacting with vanadium. So I need to focus on vanadium now. What are the possibilities for vanadium? If you go down and you have a look at vanadium, then there's this reaction. This is the only equation where vanadium is given. And that's the only one. Okay, there's vanadium. Vanadium is nowhere else. So that's the only possibility. Okay, backward can the vanadium could lose electrons to form a 2 plus ion. So here are my two reactions. And what's the rule? The rule is the lower potential is the one that likes to lose electrons. So out of these three, which one is the lower potential? You have two equations for Fe3 plus. Both of them are not as low. The lowest is vanadium. So go back, vanadium is minus 1.2 volts. So it's going to be vanadium that's going to lose electrons to form vanadium 2 plus. Okay, that's one of the reactions. And the other thing is the one with the higher potential is the one that likes to gain electrons or has the greatest tendency to actually gain electrons. So out of these three equations, which one has the highest potential? If you go back, then you do 0.77 wala, that's the one that has the highest potential. So basically, I've figured out the reaction that's going to happen. Fe3 plus is the one that's going to gain 1 electron because it has the highest E naught. It has the greatest tendency to actually gain electrons out of the three. And vanadium is the one that's going to lose electrons that has the lowest or greatest tendency to actually lose electrons. So I'm going to add them up over here. So Fe3 plus, I'm going to first write down the reactions. It was 0.77 volts. And the other one was vanadium 2 plus with 2 electrons, and it forms vanadium. And the value was, I think, minus 1.20 volts. This, I think, if you have a look at the data booklet, were the two equations that we selected. So up the next part is this is going to gain electrons, this is going to lose electrons, make the overall equation. Balance the number of electrons gained and lost. They should be balanced. So multiply the first equation by 2. and then start adding up the reactants. If you added the reactants, it's 2Fe3 plus. In the second equation, the reactant is vanadium, and the product in the first one is 2Fe3 plus, Fe2 plus, sorry, and in the second one, the product is B2 plus. Okay, that's your overall reaction. Construct an equation for the reaction. So we have constructed it using the data booklet. ये clear है Saqib? Sara, is this clear?
Yes, sir.
Achha, but now the thing is, if you go and have a look at the data booklet, not the data booklet, the marking scheme, this is probably not going to be the answer. Okay, the answer is a lot different. How did vanadium change into VO2 plus? That's the question. But where did this come from? Okay, there's vanadium changing into VO2 plus. I mean, Fe is making sense. It's the same one. Fe3 plus changing into Fe2 plus. So, ये वाला part तो हमारा correct है, ठीक है? But how is vanadium actually changing into VO2 plus? So, let's have a look at the data booklet again. Carefully look at the equations. There is no equation where vanadium is changing into VO2 plus. Okay, that's simply not existent, non-existent. So what's basically happening here is it's a chain reaction, and in a chain reaction, what happens is I would have to open just one second. Let me open a whiteboard. The problem with this question is that it's a 2-mark question, but it requires a lot of working. Okay, so we have to do the working. Just one second. Achha, so at the moment, we are at this point. Okay, we have done, and let me copy paste this. We have done this first part. Okay, that part makes, but that's not the answer. Achha, we are at this point. So masla kya was? So the thing is, the reaction is actually not going to stop here. What's going to happen is, once V2 plus is formed, this Fe3 plus, it's a chain reaction. This Fe3 plus, if there is Fe3 plus in excess, which he actually never mentioned, but if there's Fe3 plus in excess and there is leftover Fe3 plus, it's going to go and react with the V2 plus that is formed. And we're now going to figure out, okay, if there is any leftover Fe3 plus, will it react with V2 plus or not? So we're going to look at the equations again, and if I open the data booklet again, so where are the V2 plus equations? You're going to notice that पहले इसको rub कर लें. ठीक है. Now remember, I'm focusing on the equations with V2 plus. So V2 plus is involved in these two reactions. So let's copy that. So here, so there are two equations, V2 plus involved here and V2 plus involved over here as well. And Fe3 plus, again, you have two equations for Fe3 plus. Where is Fe3 plus? ठीक है, the same two equations. Both of them involving not these two, these two. So I'm going to figure out whether there is. So my just to be very clear, okay, we did a reaction where Fe3 plus was reacting with V, and there was only one reaction involving V, and we figured out it's a lower potential. It's going to lose electrons to form V2 plus ions. And there was only one reaction, Fe3 plus. There were actually two equations, but I chose the higher potential one, and I figured out this reaction. But if there is still Fe3 plus remaining, it's going to react with V2 plus again. So I'm now reacting. It's a chain reaction. The V has changed into V2 plus in the first reaction. Now I'm figuring out whether Fe3 plus is going to react with V2 plus again as well or not. So look for the lowest potential. The lowest potential is the lowest potential that we have over here is this one. But you're not going to choose this as the lowest potential because the lowest potential is the one that loses electrons. Now we don't have any V anymore. Okay, all the V changed into V2 plus. So I'm going to ignore this reaction. Okay, V khatam ho gaya. Now we are actually dealing with V2 plus. So now which one is the lowest potential? It's this one. So let's pick this up. Or this is the lowest potential now. So let's take this in the backward direction. Okay, it's the lowest potential, loses electrons. And which one is the highest potential? It's Fe3 plus. So it gains electrons. So I have another reaction now happening, and that reaction is you balance the number of electrons. So इसको 2 से multiply कर दो. Actually, you don't have to balance it. It's already balanced. ठीक है, 1 electron है. So I'm going to add up the reactants V2 plus. Reacting with what's the reactant over here? That's Fe3 plus. And the products I have are in the first one it's V3 plus, and in the second one it's Fe2 plus. So the reaction happens again. Okay, this time it's this reaction. Okay, let's circle this. So now there's a second reaction happening, but still there is no VO2 plus. But the marking scheme, where are you getting the VO2 plus from? I said, now, if you look at the reaction, vanadium first changed into V2 plus, and then it again changed into V3 plus. Now we're going to see whether Fe3 plus is going to again react with V3 plus or not. Okay, that's the question. Okay, Fe3 plus first reacted with V, changed it into V2 plus. Then there was another reaction where Fe3 plus then again reacted with V2 plus and changed it into V3 plus. Now we're going to figure out whether it's going to react with V3 plus again as well or not. So वो अब check कर लेते हैं. So I'm going to copy the equations involving Fe3 plus. वो तो यहीं पे लिखी हुई है. I'm just going to let me just इधर से copy paste कर लें. So I'm just going to cut paste this. वो मैंने यहाँ पे. अच्छा ये Fe3 plus की equations होगी. And I want equations involving V3 plus. So I'm going to go back into the data booklet and I'm going to see क्या V3 plus कहाँ पे. So you would notice that there are two equations involving V3 plus, and it's these two. So these two are the equations involving V3 plus. ऐसे इन दोनों को बीच में ले रहा हूँ. Now the thing is, I'm focusing on this fact. Whether is Fe3 plus, is there going to be another chain reaction in Fe3 plus? Is it going to react with V3 plus or not? So if you look over here, the highest potential usi Fe3 plus ka hai. So that's the one that's going to gain electrons. Now who's going to lose electrons? The lowest potential. The lowest potential in this case is this one. But the thing is, you're not going to use this as the lowest potential because you have run out of V2 plus. Okay, there is no V2 plus. So I'm going to ignore that. Okay, because reaction abhi kiska hai? V3 plus ka. After this, which one is the lowest potential? It's the first one. But ignore that as well because it's going to lose electrons, but there is no Fe. Okay? We don't have Fe in the reaction. but यहाँ पे there is no Fe, so just ignore that as well. So which one is the lowest potential then? It's the 0.341, this one. So you notice that Fe3 plus is the higher potential and the V3 plus is the lower potential. The reaction फिर से होगा, and the reaction is going to be ऊपर वाला forward में और नीचे वाला backward में. Fe3 plus, that's the reactant, and in the lower one the reactant is V3 plus and H2O. And the product is, in the first one it's going to be Fe2 plus, and in the second one the product is VO2 plus 2H plus 1. So finally this V3 plus is now changing into VO2 plus. Or marking scheme में ना, the answer that was given, ठीक है, where's the marking scheme? The answer that was given was the one involving VO2 plus. और अभी question खत्म नहीं हुआ, ठीक है? The question still continues. At the end of the day, you have three reactions. इसको जरा सही कर लें. So ठीक है. अच्छा, at the end of the day, you have three reactions now, and I'm going to copy each one of them. That's the first one. ठीक है, this was the first one. ठीक है, this was the first one. So let's copy paste all of them together. ठीक है, that was the first one. इसको यहाँ पे पढ़ा कर लेते हैं. ठीक है, रिवर्स ऑर्डर में लिख लेते हैं. अच्छा, that's the first one. फिर एक second reaction हुआ था, which is this one. और इन सारों को अगर हम ठीक है रिवर्स ऑर्डर में लिखे हुए, so that's, इसको भी तो शो नहीं हो रहा. अच्छा, so you have these three reactions. The first one over here, then the second one, and then the third one. Fe3 plus first changed V into V2 plus, then Fe3 plus changed the V2 plus into V3 plus, and then the same Fe3 plus changed the V3 plus into VO2 plus. इन तीनों इक्वेशंस को आप एड अप करो, ठीक है? Add all of them up and start adding the reactants and the products. उनको simplify करने की कोशिश करो. What would happen is कि left side or right side, ठीक है? You have the reactants, add all of them up. The V2 plus is going to get cancelled out. The V3 plus is the one that's going to get cancelled out. In total, what you would have is Fe3 plus, Fe3 plus, and Fe3 plus. So there are 4 Fe3 plus. यहाँ पे there is water, and there is also vanadium. और right side पे क्या है? Right side पे there is Fe2 plus. How many? There are 4 Fe2 plus. plus the other thing is that there is VO2 plus, and there is 2H plus 1 as well. So that's your final overall equation. Now this was an example of a chain reaction. You don't have a lot of examples like this. Okay, and it's a lot of working for it. I mean, there's no simple shortcut for this. This is a lot of working for a 2-mark question. ठीक है, it's a lot of working for a 2-mark question. कि आप पहले फिगर आउट करो कि हमने स्टार्ट किया था पहले उसने सिंपल कहा था कि Fe3 plus and vanadium are reacting, and these were the only two equations that you had. So higher potential gained electron, lower potential lost electron, and we thought that this was it. ठीक है, this was it. The reaction ended up over here. लेकिन मार्किंग स्कीम देखा तो उसमें कहीं से VO2 plus आ रहा था जो कि it wasn't visible anywhere in the equation. So then we figure out that the Fe3 plus is now going to react with the V2 plus as well. तो फिर हमने फिगर आउट किया कि वो जो Fe3 plus हम ऐड किए जा रहे हैं ना, वेनेडियम तो चेंज हो गया V2 plus में. So is it going to react with the V2 plus as well or not? So we figure out that V2 plus is the lower potential, वो फिर से further oxidize हो जाता है and Fe3 plus gets reduced. So the V2 plus now changes into V3 plus. Then we figure out that अभी तक VO2 plus नहीं आया, so then we figure out that is the Fe3 plus again going to react with the V3 plus or not? तो फिर हमने देखा कि जी V3 plus जो है ना वो फिर अभी भी lowest potential, it's going to lose electrons, and the Fe3 plus is going to gain electrons. And we figured out there's going to be another reaction, and now you're going to finally have the VO2 plus ions. And eventually you're going to add up all the three reactions, and this is going to be your final overall reaction. The only problem with this question is, I said the question has a lot of problems. There's a problem with the question. क्योंकि मैंने यहाँ पे देख लो वो 4Fe2 plus है, प्लस V है, H2O, ठीक है. Now, और उससे specifically VO2 plus का ना एक मार्क दिया हुआ है, ठीक है. मतलब you wanted VO2 plus, but the whole problem with this question is कि why is it? अच्छा, where's the question? As the whole problem is why is it a 2-mark question? Why is it a 1-line question? So that's the problem with the question. और उसने यहाँ पे ना, somebody was asking कि उसने यहाँ पे actually लिखा हुआ है कि there's excess iron 3 ions. ठीक है, so that's how we actually figure out that there is always Fe3 plus left at the end of the reaction. और वो बार बार vanadium के साथ ना react किए जा रहा है. Sara, did you get this question? Anam, Saqib, is this question clear?
Yes, sir.
Yes, sir.
Okay. So just remember that you don't have a lot of chain reaction questions like this. Usually you don't. और ये question तो वैसे ही गलत है, ठीक है? But it shouldn't be a 2-mark question. अगर होता तो at least 4-mark का question होना चाहिए था, ठीक है? अच्छा, the other thing is, when do you look out for these chain reaction questions? You look out for those chain reaction questions, especially when there are a lot of vanadium equations, for example. Vanadium की देखो, there are 5, 2 plus बन जाता है, फिर 3 plus बन जाता है, फिर 3 plus से I think it changes into, not sure what this is. It's again getting oxidized, ठीक है? So it just keeps on getting oxidized. You have a lot of multiple equations for this. So in this case, you look out for these reactions. इस तरह ना और questions भी आते हैं कुछ. Tin और iodine का जैसा question है. So we're just going to do one more. इसी तरह के questions हम कर लेते हैं. 2-3 scenarios हैं. So I'm just going to cover all of them, ठीक है? क्योंकि आपकी data booklet में सारी equations तो लिखी हुई नहीं है. So I'm going to do just one more. Okay, you might get a question on tin plus iodine. So now that's also a chain reaction. Iodine की अगर data booklet में you go and look for an equation, it's this one. It's I2 plus 2 electrons, it forms 2I minus 1, and the E naught value is I think 0.54 volts. That's it. ठीक है, that is it. Iodine का देख लेते हैं. 0.54 volts. मैंने क्या लिखा है? ठीक है, I've written it right. With tin, if you go and have a look, I said right now I'm making a reaction with tin. So Sn, there's only one equation, which is Sn2 plus, and it's minus 0.414 volts. So I'm going to copy this reaction. So it's Sn2 plus, and let's remember that this is in excess. So Sn2 plus plus 2 electrons. Sn ki na, there's only one equation. So, and that's E naught is minus 0.14 volts. That's it. So इसका आप करोगे who gains electrons, who loses electrons. So higher potential gains electrons. So that's the first one. And lower potential loses electrons. That's the second one. The number of electrons gained and lost, they must be equal. They are already equal, so you don't have to do anything. Add up the reactants. पहली वाली में reactant I2 है, second वाले में जो reactant है, that's Sn. और products को add up कर लो. So the products are, in the first one it's I2I minus 1 that's forming, and in the second one the product is Sn2 plus. ठीक है, reaction हो गया. That's your reaction. अब इसके बाद क्या करना है? What you're getting is Sn2 plus. So there is Sn2 plus that is formed, and I'm saying that there is excess iodine. तो इसका मतलब है iodine अभी भी बचा हुआ है. So is there going to be a reaction again? तो वही iodine की equation को copy paste करो. ठीक है, just 1 second. It's अच्छा इसको वैसे ही लिख लेते हैं. So it's iodine plus 2 electrons in equilibrium and forming 2I minus 1, and the value is 0.54 volts. और अब tin 2 plus की है. tin 2 plus की एक equation tin 4 plus के साथ है. And the E naught for that reaction is, what's the E naught? That is 0.15 volts. ये यहाँ पे. So this one is 0.15 volts. So ये फिर से high potential, it's going to gain electrons, and tin 2 plus is going to lose electrons again. तो वो दूसरी दफा electron lose कर रहा है. And the reaction is going to be add up the reactants I2, और दूसरे वाले में the reactant is tin 2 plus, and the products are 2I minus 1 and Sn4 plus. So that's your second. So you have two reactions. ठीक है, this one. And you have this one. So what happened? First Sn changed into Sn2 plus, and then it further changed into Sn4 plus in the second reaction. Iodine ने पहले उसको 2 plus में convert किया, and then it changed it again into 4 plus. If you want to write the overall equation, you're going to add up the two reactions. So it's going to be 2I2. Reactants को add up करो. The Sn, so there's plus Sn plus Sn2 plus, and the products are right side पे there's 4I minus 1, there's tin 2 plus, and there's tin 4 plus. Achha, what's going to get cancelled out is this one. So your reaction is that tin is basically changing into tin 4 plus, and that's your overall reaction. So इस तरह के ना ये बस there's just a couple of chain reaction questions. एक Mn के साथ भी है, so you have to remember that one as well. So otherwise बाकी सारों के अंदर ना what you always do is जो normal scenario होता है, higher potential gains electrons, lower potential loses electrons, and you stop there. ये बस एक दो एग्जांपल्स हैं जो याद रख लो. वेनेडियम का याद रख लो, मैग्नीज का याद रख लो, और टिन का याद रख लो. ठीक है, चल ठीक है. इज दिस क्लियर सारा? साकिब, इज दिस क्लियर?
Yes, sir.
तो चले ठीक है, ये कंटिन्यू करते हैं नेक्स्ट टाइम, ठीक है?
अल्लाह हाफिज।
ओके देन, टेक केयर, अल्लाह हाफिज।